Right, here we're going to learn how to sketch gradient functions and also do the vice versa. That's find the original function given the gradient one. It's actually quite easy. Just pay attention, look and learn. We'll sketch the function f dash x when you're given the original. That's the question. So one of the first things you should do is always locate the turning point, or points if there's more than one. We can see the turning point is there. That is the x-intercept. So we make sure the x-intercept is right below that. Make it in line. That's why I've lined the axes up. Then draw a line with a gradient of 1. Do it anywhere on your page. It's got up one, a long one. Now shift that, make a parallel line so it touches the curve as a tangent. That means it touches in one place. Find out where does it actually touch that curve. Right there. That means it has to be 1 high. That's why that green dot is on 1, because the gradient was 1. Let's do the same for -1, and we draw a line at -1, down 1, along 1, down 1, along 1, and then make that a tangent. Where does it touch that curve? Right there. So below there you have to have a green dot. That's at -1. Join them up. There's your gradient function. Now that is pretty easy once you understand it. This one here, we're going to do the same thing. Here we've got our original graph. We want to graph the gradient function. Locate your turning points. There are actually 2 of them here, aren't there? They are the x-intercepts. Now let's do a line with a gradient of 1. Put it there where it touches. Draw a dot at 1 straight there. Well, there's another line with a gradient of 1, and you put that there. And you can see you're probably going to get a bit of a parabola at the bottom. So let's have a look at the line of -1. This has a gradient of -1, and you put that there, make it a tangent, and right below that point you put a dot at -1, join them up together, and there we go, the gradient function. They give you merit for that, which is pretty easy, I guess. Now this time we're going to do the opposite. We're going to sketch the graph of an original function. We're given that the function is at 0 is 3, and this is the opposite thing that we're doing from the last two. We're starting with a gradient function. That's f dash x is given to you. So we're going to do a slightly different method, and we're going to write numbers for the gradient. Okay, now look where this line crosses, where it is the value at the y-axis is -2, value is -1 there, 0, 1, 2, 3, and 4. That's not too difficult. We're going to use the point that f0 equals 3. That's that dot there. And now we need a gradient of 1. The turning point, of course, is the key bit. There's a gradient of 1, here's a gradient of 2, here's a gradient of 3, there's a gradient of -1, there's a gradient of -2. You're going to get that sort of shape. Line it up with that point 3, and make sure your turning point is in the correct place. Bingo, you've done the original function. Here's fx. This one here, we're going to sketch the original function given that fx goes through the point 1, -1. Now here is a differentiated function. So we put the point 1, -1 there first. Again, put numbers for the gradient. We've got 0, 0, 1, 1, 2, 2, -1, -1, and -2, -2. Now I've put your turning points there, 0, and you can see that by lining them up, the turning points have to be in line with those grey lines. Just line them up, and there we have it. Now the second part of this graph there, that is actually guesswork. I'm not exactly sure exactly where that goes, but it doesn't matter. We've got our turning point in the right place. It's gone through the point 1, -1. I'm not sure how deep or steep it goes, doesn't really matter. So remember, the turning points are keys for these. Those are all turning points. You won't get grass looking like those last 3 yellow dots, so don't worry about it. All good.